Hello, everyone. Welcome to another episode of AWS Show and Tell Generative AI. Joining along with me is Rob Higurita, my fellow co-host, and Yuri and Pat are our guests today. Yuri and Pat are on the AWS side, some specialty folks joining us on the AIML specialty from the AIML specialty in AWS. But let me just quickly introduce myself before we talk more into the show. So I'm Anil Nadimiti. I'm a senior solutions architect here at AWS. I support customers in the Northeast. And over to you, Rob. Rob, you're on mute.
I knew I was going to do that. I saw it was on mute, and I knew I was going to forget to press it when I started to talk, because you can't have a video call without at least one person talking on mute. So I was that person for today. So for Pat and Yuri, you can take my mental note of keep yourself unmuted. So, but my name's Rob Higurita. I'm happy to be here again for another show here of AWS Show and Tell, a little bit on generative AI. And I'm happy to be here with Yuri and Pat, and of course, my host, Neil. So I'm going to turn it over to Yuri and Pat because no one cares what I do, because the exciting people are Yuri and Pat. So let's get over to this side of the house. So Yuri, if you want to introduce yourself, that'd be great.
Awesome. Thank you, Rob. So I'm Yuri. I'm a senior solutions architect, and I'm a specialist AI, ML, and generative AI. And we work with a lot of customers here, and we build very awesome generative AI apps. And today I'm going to have a chance to show you one. So nice to be here.
Thanks, Yuri. Over to you, Pat.
Yeah, hey everybody. I'm Pat. I'm here in the greater Pacific Northwest. I've been working at Amazon for about 3 years now, and I work on the Bedrock go-to-market team as a solutions architect. And Yuri and I work together to build what we're going to show you today and to talk about retail AI shopping.
All right, I'm joining from Princeton, New Jersey, and I know, Rob, you are
I'm in cold Austin, Texas. It was 60 at 3 p.m. It's, now it's basically 7 p.m. here, and it's 36 degrees. So yeah, it's gotten cold down here in Austin, Texas. Not loving it. Could warm up again, and it'd be perfectly fine. But that's okay.
from 60 degrees to 38, right?
Yeah, 30 degrees
shift.
It got cold real quick. It's super windy out too, but this is not the Weather Channel, right? So we're going to talk about AI-powered shopping assistant, which I think was cool. Yuri, we were going through before looking at it, right? Kind of doing a little prep for the show and seeing things. And I was like, it's kind of funny because last week we had one of our viewers from LinkedIn that was like, hey, it'd be great to see some retail oriented content. This is not a direct result of that comment last week, although we'd love to take the claim that, yes, we managed to pull this together in the fact of a week to find Yuri and Pat to come and do the show. It was not. It was just happenstance, pure coincidence. But
you did it.
There we go.
Take the win.
We're here.
Yeah, my chancellor. We're awesome.
And chat, let us know where you're joining from, right? So I know that we're seeing a lot of folks. Let us know. Put it in the chat. Tell us where you're joining from. Yeah,
we had all over the place last week. I can't even remember all the different places. We popped up a few different locations, and it was from, Germany, from Brazil, from I can't remember where else it was from. It was a lot of different places. So hopefully we got some different people from around. Let us know where you're joining us from. Like Neil said, that'd be great. But we should probably get a little bit into, what we came to talk about today. And we got a little bit, of course, I think we're doing the show part and then the tell, right? Or are we doing a little bit of tell and then show? I can't remember for sure.
I think we're doing the tell, I guess, right? So,
right.
Yeah.
We'll do the tell first. So we're going to talk a little bit about what we're talking about. And this was a reinvent kind of topic you all did too, right? Previously. So
yeah,
some people who maybe would have seen it at reInvent, if you went to reInvent. If not, go next year. Or this year. It is this year already, right? It's 2025. So we got reInvent together this year. Yeah. See, yeah. I'm just all over the place, but yeah. All right.
So like next year.
I know, right? It feels like it could be. I mean, it's far enough out that it could be considered next year, but it's not. So had it up here before real quickly. I'm going to pop up, and soon we're going to go through a little bit of some PowerPoint, not too much, just kind of covering a little bit about what you all covered in the reInvent topic. And that was, building an AI-powered shopping assistant. So what can you tell us about this?
Yeah, pretty awesome. I'll give it up to Pat here. He usually starts a little better than I do. But we took this to reInvent And we also, in 2025, we just came back from the NRF show. So the National Retail Federation shows, like we had a lot of customers there.
Mm.
What's up with generative AI and retail, how we get to the next level, how do we actually use this generative AI and large language models in retail. And that's a lot of emphasis on chatbots to help with the shopping assistancy. So I'll let that go, but we're pretty excited to talk about this.
Awesome.
Yeah.
Yeah, and Yuri's spot on here. I think we can move to the next slide. We did the intros. It's good to see everyone from all over the country and late for some of you. So like very flattered you decided to join us. Hope you're not skipping dinner or anything. But
It's from India, man. It's pretty late there.
yeah.
Great. Thank you.
Yeah, and I see some folks joining from India, right? So it's pretty early in the morning there.
Yeah, it's
well.
tomorrow. So
Yeah, it's
Cool,
Right.
cool. Yeah,
Tell
yeah.
us
So
about this, right? Yeah.
I think we all kind of know what the pain is here with online shopping. We've all done it. I mean, we all shop online. Of course, Amazon.com provides a great experience right now, but we can sympathize with a lot of these, and we don't have to go through all of these. But personally, when I go to the store, I've got 3 kids, and when I have to go get diapers, I have to look through 3 different shelves of diapers, right? And there's probably different reasons to buy each of them, and so product discovery becomes hard. Information overload, decision paralysis, all the conflicting emotions you feel when you're met with a massive list of products. That's the pain we're feeling. And, in short, generative AI can't help with these. And they can also make like your experience feel more personable. So if you can imagine, and we're going to talk about this more, a personalized shopping experience, not just product recommendations, but like maybe the way you like to shop is coordinated with AI, or you've got like a personal assistant to help you there.
Yeah, and a lot of choices out there, right? So imagine like when we go to the store, at least we have a few choices, but when it's online, there are too many choices, right? And which item do we pick, right? So and how do we even compare those two? And most of the time, I guess, is spent on that analysis paralysis, and probably very little time by the time we get to make a decision and do that purchase.
Totally. Yeah, and this affects your bottom line and as a business owner. So I think the next slide we kind of move into what I'm about to describe. So I don't know. I'm old enough to remember all of these, so I'm probably dating myself. But if you shopped online in the 90s, it was painful, right? It was like a book, and then anything with the word book in it, you got back, whether it was a book or not. In the 2000s, we moved on to search engine optimization, of course. And then, the experience with smartphones in the 2010s made shopping a little more personable. And then earlier in the 2020s, we got into ML search optimization. And honestly, by halfway through 2025, we're now talking about AI assistance. And so the progression of like the shopping experience has changed a ton. I don't know if folks want to share like what they remember about shopping throughout the decades, but this is kind of where we're headed. Anything you want to add, Yuri, or anybody?
I don't know, just remember GeoCities and how.
Yeah, right. GeoCities. I mean, if we think one time we looked back at the Amazon.com website, like on a previous stream,
Wow,
the Wayback Machine, right, to look at what the version of Amazon.com looked like, right, when it was books. That's it.
Yeah.
Books, right? Like now, like you said, everything that we've added on to what's there, not just for products, but all the features and capabilities. We talked in the previous episode a little bit about Rufus, right? Like the Gen AI assistant there to help you do shopping and everything. I mean, back to what you talked about before. Last week, we've been talking again about retail, and Trevor had some analysis paralysis, like on choosing which granola at the grocery store.
Wow.
So it's kind of one of those things where you're like you mentioned the diapers. You're like, I got 20 million diapers to choose from. I also got a whole bunch of everything else to choose from, right? And even more so online. So all these additions are really cool. But yeah, it'd be great to hear from the audience if you remember an old site that you used to shop on, either that exists or doesn't exist, maybe. And if it's improved itself over the years, it'd be cool to
So, yeah.
And also, like as we look at, we spoke about Amazon, right? Amazon introduced a shopping assistant, right? So talk about that as well.
Mhm.
Yeah. A lot of the motivation here also came from that because when customers saw Rufus, which is the Amazon .com shopping assistant, they're like, "Wow, how can I do that?" And I think Amazon has like one of the biggest challenges in the industry because it's such a large marketplace. So like there are products at Amazon that Amazon probably don't know those products are there because the sellers, you know, making the products available. They're creating the pages, they're creating the descriptions, they're creating posting videos. And the reviews are coming from customers, but all that happens organically. Like Amazon is just automating and allowing that process to happen. Now, how can your search be interconnected with that, right? As things come in, and then the addition of the Rufus was pretty cool because now customers can have this interaction with a little chat bot, and they can actually ask for, hey, give me a comparison of this item versus that item. Which one has the best reviews? Which one has a review? The other day I was actually buying a heater for my garage, and garage heaters, they can be tricky because you got to size it right. I live in Denver, so it gets pretty cold during the night. So like I wanted to make sure I had the right capacity to make my garage warm. So I asked Rufus for a few comparisons in between a couple of them, and I asked to show me a review by a Canadian. I want to see a Canadian who reviewed that because it doesn't get any colder than Canada and Alaska. And then I got that review and it was spot on. I sized just right, and like this person even had described how many squares he or she had in their garage, and I matched mine, and like I sized right on.
Just right onto it. Nice.
Yeah. So I used Rufus for that. So those are types of use cases and how you can help shoppers. It's pretty cool. It connects with a human need in a way.
Yeah, and then in today's session, right? So you're going to show us how to build one of these. Is that what we're doing here today?
Yeah, we're hoping for that. Pat, you want to go over this last one? Or are we good?
Yeah. Let's talk real quick about what assistants could do, and this is not exhaustive. So like we've all been to the Home Depot or we've been to a home improvement store where we don't know how to do drywall. I don't know how to build a deck. Talking with a product specialist who can help you with that is now possible. So conversing with someone who knows what they're talking about as an agent, it can become possible. You can improve conversion of products and improve shopping cart abandonment because those products that finally get in there are actually relevant to the user. You can remove paralysis in deciding what to buy. You can reduce information overload. So you can, if you can imagine shrinking a list of 100 products down to 3 that are like generatively related to what you're looking for. And then, with speech to speech on the horizon, we can actually do a lot for accessible audiences. So we can provide ways that, people who maybe weren't originally able to buy online exclusively can now do it. So it opens up a ton of doors. That's really the point of this.
Yeah, Pat, you mentioned speech to speech, right? So tell us about that. What is speech to speech for people who are trying to understand, right? So
Sure. Yeah. So speech to speech is it's more or less what it sounds like when you speak and translate, or you send audio into an FM, a foundation model, and out comes the audio of the speech response. And there's a number of different architectures for accomplishing that, but that's more or less what that concept is referring to: speech to speech.
Got it. Yeah, excellent. And Ramesh is saying, taking us back into the Amazon.com website from 1999, right? So, all right.
Cool. All right. I think from here we talk about what we built a little bit, and I do have a video of the demo that I put on the slide for y'all, but I'll show the video. I'll show the actual demo live as well. But I like playing this as as I kind of like talk through it. And so, you may be looking at it as like, whoa, what's going on with that? Is that a home improvement? And I had a lot of motivation on that, and Pat connects on that with me because he has the same frustration. And it's like, we thought about like, what is one of the most frustrating shopping experiences? You go to the home improvement store, and you gotta fix something in your house, or you want to build a little project. You have no idea where to start, right? And like, let's be honest, most of us who go to the home improvement store, we're not professionals. We don't know what we're doing. We just want to do something, and we don't want to pay for someone to do it. So you want to go there, and then you want to talk to someone, and you hope that person at the home improvement store knows how to do what you need to do, but that's not a reality as well. So we thought, well, how can we help ourselves? And maybe we'll be helping someone else. And then we had this idea of creating the Any Company Home Improvement. It's on the top of that. And this is how you go to the store in a virtual experience way. So here, I'm kind of going to walk you through. I'm clicking through some of the departments, and you can see, well, it's a bunch of like, items for my bathroom, but like, or the typical experience, in any web e-commerce store is you just go to the search bar over there, and you type down what you're looking for, which I'm gonna do on the video in a sec, and I just look for a sink, and you get it, right? It's like, if you know what you're looking for, you get it. But the thing is, like, what if you don't know what you're looking for? What if you're trying to do, and I'm going to pause here so you can see what I typed down. I would like to build an outside deck. And you guys may be asking, you're crazy. Who wants to build an outside deck? Well, I do. And
for the days that it is nice in Colorado, right? Because it is beautiful out there. So why wouldn't you want to hang out on a deck some days when it's not covered in snow? Yeah,
and I ended up doing this, and the deck is okay. It needs some work, but here's what happens, right? And then I'm activating what we call the shopping assistant. And so behind the scenes, what's going on over here, I would like to build an outside deck. I'm sending the question to one of the large language models, and it's answering to me with some like general knowledge of, before you do that, you should consider some things, right? And then from a user standpoint, you can use this guidance to formulate your next question and follow up on that question, which I do. So I go, okay, cool. I need to know my tools. I need to know how big the deck is. Maybe I need a permit. So I'm just telling you, the deck will be 10 by 10. So I gave it a size. And then from that, the chatbot can actually recommend some things already. And it's recommending things from its catalog. So if I pause here, you already recommended like some deck tiles, wood deck railing, and he also recommended like a deck stairs. And that's pretty cool because it provides that walk-by experience. Like, if you're building a deck, did you know you could actually buy those wooden deck stairs ready to go instead of building them from scratch? Like, I didn't know, actually, when I was doing this, and I learned that. So you also can provide that virtual walk-by experience. If you went to the store and there was a experienced person over there helping you, they would probably tell you about the pressure treated wooden deck stairs. Right? But if you don't know, how do you get that?
Right.
So, and then you can keep on following up. And the cool thing about this type of chatbot, it probably remembers what he told it better than a human would remember. Because the memory is out on the chat, and it's indexing that. It's that context is being taken into consideration every time you ask something else, right? So I already told you about the deck. I already told you it's 10 by 10. Now I need, decking boards. So I asked for some decking board recommendation, and I got some related products. So it's gonna come up here, and boom. So you have some cool looking like solid wood or lumber boards and so on. So that's that's just a video. I'll show you the demo in a little bit. Hopefully, we get some questions in the chat for that, and I can ask the chat.
I just want to call out the affordability of these teak wood decking boards for $75. Teak has to be like the most expensive wood you could possibly buy. I'm
It is.
here.
And I like that you called that off because, by the way, all the images you guys been seeing on the screen, and as they bring it up the live demo in a second, everything was generated with our Amazon image models.
Nice.
So are you saying that that's not real, right? So that's all
No.
generated?
All generated. The pictures are generated, the descriptions are generated, the price, the reviews, everything is generated.
Sorry, Pat. The price is just generated. It's not
Oh.
real. You can't buy teak
You
wood.
cannot buy it.
I'm out.
Yeah.
I don't like this assistant.
Yeah, I was pleased to see that it did at least recommend cedar for the boards and not pressure treated lumber to use on some of the stuff. So that's good. At least it's making good recommendations too.
Yeah, and you can imagine like this is a demo, but like there's a lot that goes into creating an agent that is legitimately helpful. You know, like maybe you could build. We talked a little bit about building like a lumber specialist who's got like a knowledge graph that builds on their understanding of lumber and structural engineering or something. Like there's a lot of different ways this could go, but hopefully what this is doing is just jogging your ideas around and seeing what's possible.
So I wanna bring it up the live demo here in a second. So let me see if I can do that without breaking the screens. There you go. So here's the actual. It's live. And y'all gonna see it looks just like the video is playing. And here's my chat. We can see some history on it, but now I can actually, you guys can ask me for some stuff. But everything you see is has been generated with our models, and it actually does a pretty good job. That's not a use case entirely. This demo is not to show how to generate products and descriptions for the products, and nobody should be generating reviews. That's, it's a demo, but that's the legal way to do it. So we generate our own data for demonstrations, and that's what y'all seeing. So you can see here is sync. Actually, that's pretty good quality. And then we have some arbitrary price, and we can ask questions about it. And so here you can find another things. And I'll talk about the architecture in a second, but we can also ask some questions.
And while if anyone is interested in generating images, right? So we had a prior episode of the Generative AI Show and Tell, where we chatted about the Nova models to generate images and animations as well. So go back to the YouTube channel or LinkedIn and check it out.
Absolutely. Yeah. So I'm gonna ask a question over here, one that we can actually have a look at the product. So I'm gonna tell this thing that I have a leaky toilet. Typical problem that you may have in your house. Let's see what it comes back with. I'm hoping to get some help on how to fix it. Okay, it actually gave me some guidance. It told me to look at, if I have a crack, check the pipes, check the flapper. Okay. And I'm being pretty vague with this chatbot. And I tell you, if anybody has like a specific question about something and they can't describe very well, they can get pretty close. And at this, the demo gods didn't help me here. At this point, they get me.
Sometimes
I do have a repair kit in this data set, so I wanted to see that repair kit.
All right, yeah.
Let's see if you can get it. Otherwise, we change the question.
So, quick question for you, Yuri, as you're going through this on the demo side. Like, Could a user, like, maybe it's not a feature today in this, but in customers that wanted to build something, could they have it so that a user can upload a picture? So if they wanted to give, like, here's my cracked toilet, like it made a suggestion of, and then it could tell you, yeah, here's what you need in order to fix it. Is that something you think we could probably do?
You could. So you could totally. That's a really good question. You could totally take a picture of your problem and use that picture as a question. And that's another use case entirely. It's image to text generation with multimodal large language models. So multimodal large language models, they can understand pictures and they can translate that to text. So you could easily build an app that takes a picture, uploads that picture, and then we can then use that picture, convert into text, and that text then will be used to do exactly what I'm doing here, ask questions, right? And then it can return the recommendations, it can return the solution for you. Like, hey, I have a crack. Here's the crack picture. How do I fix that crack? Of course, I'm not trivializing that. There's some building on.
Yeah, but it's going to take you a little time. It's not just a little teeny tiny feature you're going to add on, but the capabilities, the tech is there in the multimodal models,
The
right?
tech is there for sure. Yeah.
So
It's just
tell us,
implementing.
so tell us, right? How now going into the plumbing of the architecture? How is this all built?
Oh yeah, absolutely. So let's.
I like use of the word plumbing there. That was a nice
Right.
improvement.
I think we're back here. So here's the plumbing. So we of course you guys saw the front end. So we developed a little React front end. So we use our amazing services for hosting. Amazon CloudFront. Like if you are building React today and you haven't tried hosting on Amazon CloudFront, I recommend you do it because it's really good. So you just need a web asset bucket in S3 and your CloudFront distribution. That's it. And as long as those files in the asset are organized in the React by the React framework and were deployed with it just deploys and runs. It's really amazing. And we have some authentication, of course. So like, the way you can authenticate in React today is you use Cognito, you use Secret Manager, and you bring your IDP. But we're not here to talk about React and authentication. Let's talk about the Gen AI. So like, we integrate the front end to the back end, and we use AppSync on that case. But you could use API Gateway, you could use Lambdas, you could use another method. And on the application, we have this, and so remember that in the demo I showed you all, there was the little search bar for semantic search, right? And semantic search, we can go straight from the search bar to something like open search, right? And do semantic search, just match by word, by context, and retrieve that. Or the other option was the guided search, which we call the conversational AI assistant. And in that case, we are sending those chat messages into Amazon Bedrock, and we use the Converse API, and love to answer any questions about Converse API. And behind that Converse API, behind the Amazon Bedrock API, you can call many different models. In that case, we are using Nova models. And now we can talk all about Nova models as well. And finally, we use Bedrock to do some reasoning, understand the question, and then process a guided search. So Bedrock itself sends a request to OpenSearch. We have all the products, all the descriptions, reviews, everything about everything in their website has been indexed and saved into a vector databases. So we can talk about vector databases as well. So there's the vector databases in OpenSearch that was created with an embedding large language model as well. And everything comes from S3. All good applications, everything comes from S3. So here you go. And some DynamoDB in between that and the Lambdas for the conversation history, and the product catalog is also hosted in DynamoDB. Cool.
So we have like Amazon Bedrock Converse API, right? So for the viewers out there, Converse Amazon Bedrock is it's the easiest way to build generative AI applications on AWS, where you have a choice of large language models that you can pick any of the models and really switch between models using the Converse API without changing your code, right? So today we have model 1 that does like what you want to do, and tomorrow you have a new model that's out there. Typically, if you have to use another API, right, you would be switching the code, making changes, but Converse API makes it easier. And as you look at this, right? So Yuri, so talk about can you tell us about this guided search? I know you kind of spoke about that a little bit. What is this guided search?
Well, so there are a few ways that someone could go and do this, and the short answer is it will depend on your data set, and it will depend on how you want to answer questions, right? So this looks like a retrieval augmented generation for those familiar with the term RAG, but in fact, it's not. So we actually use a two-step large language model reasoning. And the way it works is the first step is just a direct interaction with the Converse API. And it reasons on top of your question, and it reasons on top of the history of the conversation. So the whole context, right? It knows everything you asked before. Or if you didn't ask anything, it knows nothing. But then as you ask more questions, if it can follow those questions and kind of like, I know you're asking about a wooden deck that is 10 by 10 and it's going to be outside. So if you're asking about screws, I know those screws are going to go outside on wood, right? So it knows that. So that's what the first step here does. The second step is the guided search. It may, by reasoning, so the large language models, they have very good reasoning capability. So it can reason on and that's open to the model. There's some prompt engineering telling the model, hey, this is a good example on when you should search, or here's a good example on when you should just answer the question. If he reasoned and he decided that it's a good moment to search for products, right? He activate this is like a directly search to open search, and we retrieve a list of products that match a description, and we'll rank which one is the best product for the context, and then you will use that answer to respond. So many would just say, this is retrieval augmented generation, but it's not the typical retrieval augmented generation. And we had some technical reasons to do it that way, but we could have done with RAG as well. I hope that answers the question. It was a long one.
Right. And then when we talk about RAG, we again, you have knowledge bases there, right? So knowledge base, can we dwell on that a little bit and tell like what we're doing with knowledge bases, and probably zoom into that.
Yeah, absolutely. Like, so over here, in fact, we used. So, and Pat can even talk about that more extensively than I can. But Amazon Bedrock has a feature called knowledge base. And in knowledge base, you can create the vector databases with the information for your RAG very easily. In this case, we did use OpenSearch, and we did not create a knowledge base from a S3 bucket. But it could be done from an S3 bucket. It could integrate with other data sources. And if you're using Amazon Bedrock API, you can actually make a RAG call to that knowledge bases directly. And then you're generating from that knowledge base. Pat, you want to add something on that?
Yeah, and we chose OpenSearch serverless here because it supports vector searches. And to Yuri's point, like there's a million different ways that you can choose to create embeddings out of your product catalog. I'm sure most enterprise e-commerce companies have already, decided or are exploring this now. But what we did for the demo is we just basically took the product description and we created an embedding out of it, and that's what we used for our vector search. We also OpenSearch supports classic text search too, which does a great job. I mean, you can still use that for RAG contents, but there's other ways to do it too. So you can take, I think at one point we experimented with taking commonly asked questions about this product, and we use those in our embedding to maybe improve results a little bit. So there's lots of ways to do it. The point here is to just be intentional about how you're going to embed your chunks of text. What are you going to embed? What's maybe better for classic text search? Because that does do a great job in a lot of cases.
And to your point, Pat, like when we create embeddings out of the text, and that's all stored in the OpenSearch database right here. So when the user question comes, that's also converted into embeddings, right? And then a matches. That's where the semantic search happens, right?
Yeah, the semantic search is created, is conducted because the question, the natural language question, is itself converted to an embedding. It searches in a multidimensional space and it brings back all of the embeddings that are closest to that in meaning. What I think a lot of customers start reaching for once they get there is they're like, great, I got some nearest K neighbors of this semantic meaning, but they're not that accurate. What we always suggest taking a look at is re-rank. So you can actually re-rank the results of your vector embeddings so that they're more closely aligned with a ranking associated with your embedding. Because often what happens is they're never ordered by the semantic similarity. It's just here's 10. They match semantically. Yeah.
So that means when we search for something related to deck, right? So you can re-rank it. And
yes. Mm-hmm. Yeah. So if you were to search for, like, I'm building a deck, it's going to go through a vector search in OpenSearch, and it's going to pull back all sorts of things related to decks because the word deck and the meaning of the deck is likely in a lot of those. You would then, as a second step, re-rank them so that the semantic meaning that is most closely associated with the question is near the top of the results.
And is that re-ranking built into this current demo, Yuri? Is that essentially like, did you use a different model? What do you do? How did you accomplish that?
Yeah. So, I mean, we built with the Converse API because we can swap the model at that point, and that's the great thing about this API. And just to clarify, right, it's like a lot of people out there thinking, like, well, do I need to use the Amazon Bedrock API to use Amazon Bedrock models or choose models from Bedrock or from Amazon? Not necessarily. We have many levels of API access. You have the AWS CLI, you have the other APIs, but this really helps with not just the experimentation, but to scale and orchestrate your application. So you may have use cases where you're going to be using more than one model. You may have use cases where for certain slices of your website or certain interactions of that chat, and we can start talking about agents and how to orchestrate that stuff. And some folks out there are familiar with LangChain and other tools to, start slicing that type of interaction. The Bedrock API really allows you to send those requests to different models and different knowledge bases through different API endpoints and without changing your code, but a model ID. Like you build a class, whether you're using Python, JavaScript, or whatever it is, most languages, you're going to be able to accomplish that very easily. And by dynamically changing those model IDs or endpoints, profiles that we have right now, so you can do multi-region, you can call different models, right? And that's the same for your embedding down there. It's like, that embedding, it's using, we used both on this use case, we tested both with Titan and we also use Cohere, and we experimented with a couple others and they all perform well. So
And I think Trevor kind of called this out too. Thanks, Trevor. Like choosing your embedding model is a whole exercise you can absolutely go down a rabbit hole on. Like there's, depending on the task that you're using it with and the size of the chunks and the whatever it is you're trying to do. We actually use Cohere and Titan here. We made it so that we could toggle between the two for discussion purposes. But yeah, there's tons of embedding models out there.
And to Trevor's point as well, Trevor joining us from the air because he's not on air with us today, but he is in the air. But he did say a little bit ago when we were talking about the KBs and doing this, and you mentioned earlier about LangChain. You know, KB sounds simpler than doing it LangChain style, but so yeah.
Yeah, awesome.
And then over there, right? Look at number 6 there. It's like the conversational history, right? So when we ask the follow-up questions, you're storing that in DynamoDB, and what's happening there, right? So how are we using that history, and how are we sending that to the model again?
Yeah, that's another one that there's like probably 10 different ways you can do that. And if you look it up, we have published best practices for memory buffers and memory chains for chatbots and generative AI use cases. And we have showed customers how to do with lambdas and integrating LangChain, if you use LangChain, no LangChain, just Bedrock. DynamoDB performs really well just because, DynamoDB is cheap, faster, incredibly reliable. So, and the type of data that you're using is, just text data from the chat. So DynamoDB performs really well. There are other use cases where other types of databases or services can do a better job on that. But for this one, DynamoDB made a lot of sense. So like what that DynamoDB conversation history is doing is just as we asking questions to the model, it's saving the user question, the model response, the user question, the model response, the user question, the model response. So every time we make a request, right? We can actually invoke the history and give the model
the
context of what came before the last question, right? And of course, you got to do some management there because, like, if the conversation gets too large, right? So that is a threshold, and that is some summarization that you can do on that conversation to help the model further. But that's use case specific. You got to, make a prediction on, well, how many questions related to a single thing may a user be asking, right? And you got to predict that a little bit and allow for some testing. But I don't remember exactly how long is the buffer for as on this use case, but and also, of course, we got to talk about cost. If you're like sending that huge buffer into your model all the time without needing that, you're sending a bunch of tokens and then you're paying for more every time you're trying to understand the context of the conversation. So the trick is you want to send as little as possible and stay within context, right? So there are some use cases where you may even want to summarize that conversation history before you send it in.
Right, and then those are various other use cases where you have caching as well, and that caching support as well. But also, like in the chat, we have question from one of our viewers. Oscar is asking us about guardrails. So how do you include guardrails? Because whenever we have a chatbot application, we always want to make sure that it has safety features built into it.
Awesome. There are actually two features from Bedrock that we used on this demo that are not showing on the diagram, and we can speak about them individually. One was guardrail. We do use guardrail, and we can go down into each one of the type of large language model features for protection of your API calls that you can add. But we do have profanity. We do have, a bunch of like injection protection. We had pretty much all the features of guardrail, they are activated on that, right? So, if you ask anything, if you go on this chatbot and you ask, hey, can you help me make a bomb? It will right away shut you down. It's like, I cannot answer that question, right? or if you get anything that is like a type of web front injection that you can dump on the chat and try to mess with the API, we'll also block that. So we can spend an hour here just on guardrails, but so I bet you can anything today if you like it. But so we're using guardrails extensively there.
And Trevor is asking the chat if we should do like another episode just on guardrails, because as you said, Yuri, like there is a lot to chat about guardrails itself.
Yeah.
Yeah, it's one of those things that when you talk to a lot of people in Gen AI, they kind of hand wave all the guardrailing that makes a workload real. And so, yeah, I think a full episode would be totally warranted there.
I like that. It does hand waving real. Like this, you don't need to know.
It'll be fine. It's not going to
guardrails are not
at
your
all.
concern.
Yeah.
So,
super. I think we saw a question here for like how I really wanted to answer the question how we evaluated the results.
I think you're looking at this one. A little from Oscar that asking also, how do you eval results accuracy? I was going to ask you. You saw it. Good. Because I think it's a great it's a good thing to talk about, right? Like it's also an important aspect. Guardrails important as well. Accuracy, that's kind of an important thing, I guess.
Yeah. So I'll tell you all two things. So Oscar, you should check it out. We have this new feature called model evaluation. It is part of Bedrock, and I wish we didn't have that feature when we built this. It was precedes that feature launch, and so we did not use model evaluation Bedrock, and I wish we had it because it would be awesome. So we use a different framework, but basically the way you can use large language models to evaluate large language models. They do a great job on evaluating that. So think of our use case is very specific. The more specific a use case is, the easier it is to evaluate if the model is responding that correctly, right? So for our use case, I'm asking a question and I'm expecting it to return a product that matches the context, right? So we basically had to design another model that would check that context, right? So given context A, response B, did it perform well or not, right? And there's some, I don't want to get into the data science, but we use some, official metrics and types of mathematical evaluations to get to that.
Yeah, and just to add there to what Yuri said, right? So there are features from Bedrock where you can actually, pick the data sets, right? Again, these can be readily available data sets. You can upload your own data set and then conduct model evaluation between the choice of the models that are available to really pick and choose which one performs well for your use case, right? So maybe for the plumbing use case, you probably trained a model and you want to check if it's actually performing well. And then again, this is Bedrock makes it so simple, whether it's guardrails, setting up guardrails, or whether it's actually doing model evaluation and bringing your own data set to do that model eval, right? So there's a lot of chat that we could do on that topic as well, right? So there is a lot of interest that we see just coming from the chat here, and we could prioritize those sessions in the upcoming episodes as well.
Yeah. Go ahead, Pat.
Well, I was going to say that's a big topic right now for customers is how do I make sure this model is performing with a level of accuracy I'm happy with? And I think, the most robust solutions I'm seeing are customers have their own data sets that they've grounded that they know are true. And they're testing that against the model to see like, okay, I have this like shopper, here's what they bought. Here are the questions they asked, and that's their grounded data set, roughly speaking. And you measure to make sure the model's actually suggesting those products. Maybe it's getting 2 out of 3, maybe it's getting 1 out of 3, but in the aggregate, you can roll all those up and measure many different models.
Yeah, Oscar is checking out the model evaluation right now from the AWS console. So yeah,
nice.
Sure, yeah. Model as a judge is the way for a lot of use cases. And a lot of other use cases is still, the typical evaluation is the typical AI machine learning evaluations. Like you need ground truth data, and that data needs to be quality data, and you're going to evaluate against it. It's like, large language models are really accelerating that, but some of those principles didn't change. It's still the classic science of evaluating models.
Right, and we also have a comment from Andres talking about grounding the results, responses, right, in the data set that we have.
Yes, very good. That's actually one of my favorite features, Zing guardrails. It's really good. It's just really good. You really can get like a large corpus of data and add that to your contextual grounding, and instant get much better answers that are actually what you want the model to answer without any fine tuning, without any. It is a secure feature because you're removing hallucination, but actually helps a lot with the quality of the answer. But big shot is like, the model is not going out of the context. It's maybe we should define what contextual grounding is a little bit if we have time, but it's really good.
We have a little bit of time left, so I mean, it couldn't hurt to go over it for anyone who has no idea, or it has little idea and would like some deeper info. So they might as well go a little bit into it.
Yeah. So think about this use case that we built with you asking questions about certain products, right? And then let's say, and we didn't block the model that way because we wanted to be very conversational. But let's say that for your use case, you want to make sure that the model can only answer on how to use a specific product based on the product sheet or the product instructions or the product data sheet. Let's say your product is very technical. Could be a medical product, could be a medical device, or it could be like, something that's a chemical product that can hurt someone or it has poison in it. Make sure that the model is giving like very precise information about how to use it, right? You can make, at the moment that your large language model is recommending that product, you can have a logic that will force the data sheet, of that product into the contextual grounding. And the only source of answers that your model will give from that point on that product, it's coming from that document, right? So it can give it can put words around it, and so it can build a sentence, but it's not going to come up with information that is not out of that sheet, right? Information that came from the general knowledge of the model. Did that make sense?
Right, to make sure that we reduce the hallucinations and really try to ground the responses, right?
Yeah.
I see Pat is unmuted on.
Yeah, I was just going to say, in addition to what we keep hearing customers doing to make sure that the responses are factual, distillation's becoming a topic a lot of customers start talking about, because you can teach a model something like product suggestions or in conversations that have been conducted with a customer, and you'd like to teach a smaller student model to do that with a high level of accuracy for your business. Distillation becomes pretty relevant, and we see that discussed more and more with customers who are maybe not at the very beginning of the GenAI journey, but they've got something in production and they're trying to fine tune it a little bit. And Bedrock does support distillation.
You can actually do distillation with invocation logs from your production data. It's integrated. If you're using Bedrock for your application for 6 months and you turn on invocation logs, you have all those logs in S3. You can just dump that into the distillation, and then that model will synthesize data, synthetic data generation on your production data to make that model answer appropriately for that data set. So it will make the model a lot faster on those questions. So,
and Trevor says that distillation is his new favorite feature out there.
It's going to get wild.
Yeah, and again, just looking at the distillation, right? So why would someone want to do that? I know that if there's a larger model, it's able to respond and it performs better in terms of the number of parameters that it's trained on. So why would somebody want to really use a smaller model? And how does that distillation? I know you've answered some of that, Pat, but how does this fit in, right? So is this a cost conversation? Is this a performance conversation? What is this?
Yeah, usually a cost and performance thing. So, and we often see it with customers that are running a large model, and they're like, "Look, I'm getting great performance out of this, accuracy wise. It's fixing or it's solving the right problems, but we'd like to just tune and optimize for cost a little bit, for latency." And yeah, the idea is you prompt a teacher model, and the teacher model teaches a smaller student model how to correctly respond to the question. So you're simulating a teacher student relationship. It's not the same thing as fine tuning, but it's appropriate for the tasks that are finite in number. So for like ad hoc conversational type shopping, maybe not. Maybe for a specific department over a span of time, you could maybe get close to that. But it's great when you are already using a model and you just want to improve the speed and the cost.
Excellent. Right. So yeah. So there's a lot of questions in the chat, and I see that people are speaking about cost. DZCF says speaking of cost, right? So yeah, Trevor.
Yeah.
Trevor, I see you're active in the chat, right? So and distillation is your newest favorite feature.
Yeah. Yeah.
We do offer, so with Bedrock distillation, we will be offering Premiere as a teacher model. So when Premiere does come out, you'll be able to teach Pro and Micro and Light as students. And we already support, I believe it's Sonnet and Haiku as teacher student combos too. So that's not a new idea. Distillation isn't new. We just make it that much easier to implement on Bedrock.
Nice. That's awesome. Well, we've covered a lot of stuff today, I feel, but a lot of like really cool things, right? Like all stemming from an AI powered, shopping assistant. We talked a lot about how that just works, but then there's all the different elements of things, right, that go and tie into it that are kind of like different backing components and things that, like Pat said, we just kind of hand waved over because we're like, it's there. It's just it's maybe not as beautiful as some of the other parts of the demo, right? So, but still important in the actual functioning of thing to make sure that it all works and goes well. So all really cool stuff. Appreciate it. So I don't know if Anil or Yuri or Pat, if you got anything last that you want to say before we wrap up tonight, but I was to let Anil wrap us up.
Yeah, I think the only thing I'll say is like, there are a lot of ways to build with generative AI. Just if you think just of AWS alone, right? There are like lots of ways you can go and build a awesome app or solve a problem in your company or in your whatever that you do. But I do believe Bedrock is the best, easiest way to start, right? It could be the case that you're gonna get to Bedrock and you may think that, well, none of the models here do what I need, and I may need to train my own model, fine tune my own model elsewhere when I need a model that Bedrock doesn't support. But like, you most likely will find out that faster if you use Bedrock as well, or you may never go away. So I do think if you are starting right now, Bedrock is a great place to start.
Nice.
Excellent. And then coming up next week in the episode, we are going to have a session, an episode on Bedrock data automation. And Bedrock data automation is where you would like to get insights from unstructured data like images, documents, audio, and then as soon as you upload them, we're going to show you, in a demo, how Bedrock is going to make it simple and easy to build your generative AI applications.
Yeah.
Yep. With that said, tune in same time next week.
Yeah. Thanks everyone for joining, and thanks Pat and Yuri for being here. Appreciate it.